So this video is mainly for the students who were not there on Friday when we did the labs. We started 3 labs on Friday. One was called the hot tub problem. One was called the flu epidemic, and we didn't quite finish the sign on the dotted line. We're going to finish this on Wednesday. So here are the situations. So one situation that we're doing is called the hot tub problem. And it said, let me just get a, it said Perry is designing a hot tub that will that he will locate behind his house. He has 36 square designer tiles that he will use to build a surface in his yard where he will place his hot tub. He wants to use all the tiles, but does not yet know how he will arrange them to form the base of his hot tub. If his hot tub will be rectangular, so it has to be rectangular, how many different rectangles with an area of 36 square tiles does he have to choose from? So I gave everyone cubes, but here I'm just going to show us with this virtual situation. We have 36 tiles and we want to get rectangles. So if I am doing this, they have to touch. Okay. So if I move this, for example, get them all situated here. Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 in a row, and I have 4 rows of 9. Okay. And so this would be one situation. And what we did is we did a table and we wrote out every single situation. Now, we really are looking for an area of a rectangle of 36. And area is equal to length times width. Okay, just trying to get these here. So if I am doing this, this side here is 4. This side here is 9. So 4 times 9 gave us 36. So that was a possibility. Okay. And so we did a table. So let me just get my table up. And for our table, we had 2 columns. One column was, I think we had width. And then we had length. And so when we're doing this, I said that I had basically 4 rows of 9, which gave us 36. That was one possibility. Basically, I want things that multiply because length times width is equal to area. I want 2 things that multiply to 36. So if I want all possibilities, I'm going to start with 1. 1 by 36. 2. 2 by 18. 3. 3 by 12. 4. 4 by 9. 5 doesn't work. 6 by 6. 7 doesn't work. 8 doesn't work. 9 by 4. And what you'll notice here is these are the same but reversed, because one situation might be where I am doing, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in another situation, I might be going 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So it really depends on how your backyard is. Okay, so we're going to talk about both dimensions. So then the next one is going to be, since I have 3 and 12, I'm going to have 12 and 3. I'm going to have, I had 2 and 18, so I'm going to have 18 and 2. I had 1 and 36, so I'm going to have 36 and 1. And those are all of the possibilities. Okay, so that's one table that we need to have. So if you didn't get that, you want to copy that down so you have that table on a piece of paper. Then we did another lab. Okay. And so this one here, let me just jot down. This was the hot tub lab. The other one we did was a flu epidemic lab. Okay. So let me call it flu epidemic. And for that one, let me get the situation here. So in this situation, this local crisis flu epidemic, health officials in Parnopsville are concerned about the recent outbreak of the flu. While scientists are working hard to find a vaccine, the town leaders are turning to you to predict how many people will be sick over time. They hope to find a vaccine in a week. Here are the facts. The epidemic started on day 0 when Velma and Stanley returned from their exotic jungle vacation with symptoms of the flu. So that's day 0, Velma and Stanley. Each day, a sick person infects 2 additional people. The town of Parnopsville has 3,800 citizens. Okay, we use beans to do this, okay? And we were trying to figure out a pattern and figure out how long it would take for all 3,800 citizens to be infected, okay? So in this situation, what we can do, let me get my grid back. So let me make a table. So we're going to have day and number infected or number sick. Okay. So day 0, we have Velma and Stanley. So that's going to be 2. And we're going to find day 1, day 2, 3, 4, and so forth. Okay. They wanted to see if we could get this done within a week. Okay. Remember, there are 3,800 citizens in Parnopsville. So for this one, what we can do, okay, if I start, let me just get some, if I start with 2 people, okay, so that's Velma and Stanley. That's day 0. Okay, they are each going to get 2 people sick. So if I count right now, I now have not 4, but 6 people, okay, because Stanley and Velma plus the other 2. And then what I'm going to do is now let me take these 6 people now. 1, 2, 3. So 1, 2, 3, 4, 5, 6. So these 6 people are each going to get 2 people infected. So each one of them is going to get 2 people infected. And so if you count this, I basically have 6 sets of 3. That's what I have, 6 sets of 3. So that is going to be 18. So then what I'm going to do is I'm going to take those 18 people. Okay, I'm going to take those 18 people. I'm not going to draw them all out, but I'm going to have 18 people. Okay, and every one of those ... 18 people is going to be getting 2 people infected, 2 people infected, 2 people infected, ... 2 people infected, 2 people infected, 2 people infected. And remember, this was a total of 18 people. And you see that each time I'm going to have 3 people infected. So basically, I'm going to take 18 times 3, which is going to be 54. So what you'll notice is happening is basically I am multiplying by 3. 2 times 3 gave us 6. 6 times 3 gave us 18. 18 times 3 gave us 54. If I take 54 times 3, I get 162. And then if I times that by 3, I get 486. And I'm going to times that by 3. And I get 1,458. So let's look at day 8. I'm going to times by 3. and I ended up with 4,374. So you'll notice I did not get exactly 3,800, but on day 7, I didn't have all 3,800 people infected. Only 1,458 were. By day 8, more than 3,800 would have been infected. So those 3,800 would have been infected on day 8. So this was the other situation that we had. Now, the one that you guys are going to be finishing today is the sign on the dotted line. Okay, we didn't have time to get through this one the other day. So for this one, certain legal documents, such as those used when buying property, sometimes require up to 50 signatures. How long do you think it might take to sign all of the documents? To find out, collect data as one person in your team signs his or her first name. Have another team member use a stopwatch, or you can use your phone, your stopwatch on your phone, to time how long in seconds it takes to neatly sign his or her first name 2 times, 3 times, 5 times, 7 times, 10 times. Be sure to record the time it takes for each number of signatures. In order to collect good data, have your team member practice signing his or her name a few times before you start. This is not a speed competition, but rather a way to calculate typical data for one person's signature. So you want to sign your name, your first name, as you normally would. So let me get back to our table here. Okay, so this is going to be sign on the dotted line. You're going to have one person in your group sign their name. And if they want, they can get a whiteboard pen from the tubs and do it on the whiteboard desk or on a piece of paper. And what we're going to do is we're going to have number of signatures and seconds, how many seconds it took. And they want us to do 2 signatures, then start all over, do 3 signatures, then start all over, do 5 signatures, then start over, do 7 signatures, and then 10 signatures. So one person's going to do the signing, one person's going to time it, and the others will record it so that we have the data. What I would recommend for the person who's signing, maybe number it 1, 2, for example, 3, 4, 5, 6, 7, 8, 9, 10, so that when you're signing, okay, you aren't going to have to go back and count, okay, and then just start all over again. So for example, if I'm signing, I'm just going to do my last name. You guys are going to do your first name. But let's say I do Ranny. Okay, I'd be timing, someone would be timing it, and then I would jot down how many. Then I'm going to start over, and this time I'm going to do 3 signatures. So Ranny, and then I'm going to put that for 3, and then go from there and do 5, okay, and then do 7, and then do 10. So get that data from your group. Then what we're going to do with that data is we're going to be graphing it. So pause the video and gather that data. So once you have your data for all 3 of them, okay, the one that you guys were getting was the sign on the dotted line. Then what you're going to do is take your data and you're going to graph it on this assignment here, which is the next assignment in your module. Let me get the module up so you can see. It is it's on this one here. Chapter 1 lab graphs. That's the one you're going to be going to. And that's going to give you this. And so you're going to graph your data. You're going to plot the points. Okay. So 1 comma 36. So width is my X and length is my Y. So if I'm going to do 1 comma 36, choose a color that's not black so you can see it. So 1 comma 36 is going to go here. And then 2 comma, remember, was 18 and so forth. So then you're going to plot that. After you plot that, you're going to describe the graph, describe the shape of it, and anything you notice. Then you're going to give the coordinates of the point where X equals 3. So if you were to go to 3 on your graph and you were going to go up until you hit the graph, where is that going to be? Basically, they're asking us, this is going to be 3 comma what? That's what they're asking us. And then they want you to explain what that represents in terms of the situation. So remember 3, which is would be the width of the hot tub. Okay. And the Y is going to be the length of the hot tub. So you want to be precise for what this particular problem is going to be. Then you're going to do the same for the flu epidemic. Okay. Now you're going to have to approximate these because these ones we got pretty big. So just approximate them. Okay. Then you're going to do the same thing. You're going to describe the graph. And then again, you're going to try to figure out 3 comma what, and you're going to explain in this situation what that means. Remember, your X is days and your Y is the number of people infected. And then this was our sign on the dotted line. Okay. They gave us 0 signatures. That should be 0 seconds. Okay. That should be 0 seconds. Then we're going to fill in the rest of our data, graph it, and then again, answer the same 2 questions. After you do that, you're going to move to 1-14 and you're going to be answering the questions that they ask here. Okay. These questions, and then you're going to submit that. So good luck with this. Hopefully everyone will be able to work together and get it done as a group.